Open up the room and we will begin.
Okay, great.
All right, good afternoon, everyone. I would like to welcome you to today's program, Laser Scanning Training Session, View, Measure, and Model with Multivista. I'm Margaret Stella Malikian, Programs, Research, and Publications Manager with AIA Baltimore. This course is approved for one AIA CES HSW. We will be providing the links to receive credit and course evaluation in the chat box. I would like to introduce the presenters. Mark King is Product Manager, 3D Laser Scanning at Multivista. He has extensive experience in the laser scanning space and for the past 6 years has been working with Leica Geosystems, helping major construction companies throughout Europe, Asia, and Africa adopt reality capture tech. Presenting with him is AJ Ballou, the 3D Solutions Manager for laser scanning at Multivista, and he has been with the company for 10 years. His role is to research, develop, and train various workflows in 3D technology and help with their franchise adapt service to a wide variety of existing and new construction projects. And lastly, Jason Donahoe has been with Multivista for 10 years and is the Senior Regional Planner of Multivista Mid-Atlantic. Jason credits his decade-long experience in development and his degrees in advertising, business, and photography as the unforeseen perfect springboard for his division's success in showing the world what Multivista is and growing the company's portfolio of service and clients. For today's discussion, please add any of your questions into the chat box and Jason will read them at the end during the Q&A discussion. And the presentation is being recorded. With that, I would like to pass it off to Jason and the rest of the team. Thank you.
Hi, folks. Thanks for joining us today. I know that we're all looking forward to a nice, refreshing summer as we hopefully start to escape our COVID pandemic environment. So I appreciate you taking time today to join us and learn about some of the latest technology in reality capture. A little history to us. We've been sharing accreditation hours with AIA over the years. About over 11 years ago, we opened up the Mid-Atlantic region, and we're doing AIA credit hours on this thing called emerging technologies related to photographic as-built technology. The concept from our pioneers was simply to take photographs and then overlay them to design drawings in a frequency-based and progressive environment in a space where you could use it and share the information. So we've stayed true to that capability. We like to perfect the different boxes of visual capture that we use until we deploy it onto the world. We operate as a service center, a third party, if you will, capturing all this visual data that is overlapping and very concentrated to your critical path milestone and scope related, whether it's a bridge or a hospital or a restaurant. So obviously we have an idea of where the world is headed with this emerging need now, especially because of COVID, to have visual remote access to your project. But we also service this as a life cycle management tool, giving the ability to see inside your walls, floors, ceilings, slabs, elevations, foundations, for the life cycle of your asset. So it's truly a full stakeholders tool, and the owner is a great benefactor because they get to have this enhanced as-built. What has emerged is the ability to leverage 3D laser scanning in a lighter environment, and we're going to show you and educate you guys on what that adoption and deliverable is from our portfolio, but in a more educative environment. There's no data barriers in the new 3D laser world. You don't have to be a BIM expert to be able to use point cloud data. You can use it in a photographic environment, logging into a portal and share it across all your stakeholders.
Leave it like that. Yeah.
You guys there?
Right.
You're good.
All right.
Hello?
You're good, Jason. Continue.
Okay. All right. So sorry. So just in our Mid-Atlantic footprint, from a photographic standpoint, we've captured over 100 million photos over the last 10 plus years. That's averaging about 100 projects, construction projects of different nature, between our DC, Maryland, and Delaware markets. So without any further ado, I'll turn it over to our 3D laser scanning expert, Mark King, and he'll delve into this evolving or emerging world of where laser scanning is headed.
Thanks, Jason. Appreciate it. And thanks everyone for joining us today. Appreciate you spending some time and coming to listen to us, and hopefully we can share some information that is new to you and helpful in talking about some of this new technology and these new workflows that we see growing in demand every day, every month, kind of every year for the last so long. As I was introduced, I've been involved in reality capture in laser scanning for almost 10 years now, over 10 years, when it was quite early in terms of people starting to scan, to the point where it becomes very common now that ourselves as a company, other companies, general contractors, architects, own scanners, are doing scanning, or at least going out to service companies to do it. And I just want to go through a few of the reasons why we see this change. So there are plenty of challenges today, and obviously we can't list all of them. But some of the key ones that are kind of the real drivers for 3D laser scanning and reality capture in general is the lack of existing information. A lot of the world that we live in today has been built and is going to be renovated in the day, in the years to come. And actually a lack of existing information to better plan renovation projects, refurb projects, even understanding the lay of the land for any new construction project. Capturing reality helps projects deliver more accurate designs, more accurate scheduling, more accurate construction plans for their project. So that's how reality capture can help with this lack of existing information. The other part is accuracy of data, and really, how accurate is the data that was collected 30 years ago with a tape measure and a piece of paper? It's probably, one, not so accurate because it was a challenging method for capturing the information, and secondly, if it was happened 30 years ago, then how accurate is it? Does it represent today's building or today's asset? The next one is productivity. Obviously, there's always a demand to be more productive, to be more efficient with the work that is being done. And really, this is a driver for the industry in terms of being able to build faster, be able to design faster, being able to do things better. But at the same time, internally, better productivity typically results in more profitability, which is ultimately the aim for every business. So if we can provide something that helps you be more productive to avoid costly mistakes, we believe reality capture could be one of those tools that helps in that way. And then finally, and I'm sure most people on this call, if not everyone, there is this drive for BIM or digitalization, some even to the point of digital twins. And this drive for digital information, accurate information, and that's the I in BIM, as you probably all know, is again a real driver for laser scanning and reality capture, where being able to actually digitally represent what's there in reality on site has huge benefits downstream in the design, construction, and even the asset life cycle in terms of having that accurate information. So some of the challenges. And going back to that, how accurate is your data? I always like to refer to it as a kind of analog versus digital mindset. We talk about the fact that I'm sure quite a lot of the people on the call today have gone out into the field with a tape measure, maybe even a laser distance meter little device, and have tried to validate floor plans or even create floor plans with that. It's a very time consuming. It's not necessarily particularly accurate. And does it fully represent the building or the asset in its entirety? Probably not. So really going to a digital mindset is using technology like laser scanning to capture that information. It's a full 3D data set that's being captured. And I'll cover a little bit about the technologies just so those of you that are unfamiliar with it understand how it works. But essentially it's about going from this old way of thinking, an old way of working, to a new way of thinking and a new way of working. And really we break the value of 3D laser scanning and reality capture into three parts. Capturing reality, I'm going to talk about, and I'm going to talk about the technologies just so you're aware of how it works, maybe what questions to ask if you're interested to either go out to a service company and procure laser scanning. The other part is connecting teams. So once we've collected this amazing data, how do we share it effectively with lots of people? And I'm going to pass over to AJ for that section. And then finally, which is probably something that you're more familiar with, how do we generate CAD and BIM deliverables from this reality capture data that we're collecting? And I'll cover that, and AJ will hand back to me on that point. So apologies if you are already familiar with laser scanning, but I feel we have to do a base level understanding for those that are maybe very new to laser scanning and reality capture. So the devices on your left of your screen and the right of your screen, these are laser scanners. They are different types of laser scanners, and each different type of laser scanner, depending on the manufacturer, depending on the model, has different parameters. One of them is typically how far can it scan. So one can scan 60 meters, the other one can scan 150 meters. There's even scanners that can scan over a kilometer in distance, so they can actually capture and measure information at a long range. Speed is another parameter. Resolution in terms of how much it scans, things like this. This is all variable on the scanner. But actually, each scanner has two main parts. The first part on the left is the laser part, where it gets its name. And effectively, what the device does is it fires out a laser beam. And when it hits an object, it makes a recording. It measures a point in space, in 3D space. And this is an X, Y, Z coordinate. Rather than doing it just once, these scanners will scan hundreds of thousands, if not millions of times per second. So these things are rotating and firing out a laser, an invisible laser, and they're measuring millions and millions of points a second, and in a matter of minutes can capture a full 360-degree picture. And that's what picture you're seeing here. This is essentially a point cloud that's created from millions, if not billions, of 3D measurements in 3D space. The second part is the camera part. So as well as scanning and in terms of taking a laser measurement, all these devices typically have a 360-degree camera built in. The reason we have that is because we can take a 360 picture and we can actually overlay that on the point cloud, and we do something called colorization, where we turn something like this and we actually attribute colors to it. So when it scans concrete floor, we can apply the color of the concrete to that point, and it makes the point cloud easier to understand and easier to see. Obviously, with cameras, you need light. So the better the lighting, the better the imagery will be. But actually, the laser element doesn't need any light. So we can actually go into a room and we can scan a room in complete darkness, and we'll get an accurate 3D picture of what's going on in that room. We wouldn't be able to take images, but we would be able to take a 3D picture as such. How does it work? So we take that device and we set it up in the field on a tripod, and we press go, and that thing will scan for maybe 1 minute, and that captures a singular position. Because it's a line of sight technology, therefore it can't see through walls, it can't see through floors. So to capture a complete building inside and out, or multiple locations, we have to move the scanner each time and then connect those scanners together in a process we call registration. So effectively, each of these dots that you see here is where we've set up a scanner, and we press go, and then the lines are the connections that we create together. It is relatively straightforward to get a scanner, to press go, and to get a singular scan. You'll get a very nice 360-degree picture point cloud of the room with one scan. The art of scanning properly is, how do I bring all those things together, where we're scanning 10 times, 100 times, 1,000 times. We have projects where we've scanned several thousand times on one project, and all those thousands of scans have to be linked together to create a full 3D picture of the site itself. And then once we have that point cloud, we can use that as the framework for lots of different things. And that's really the value of the point cloud. The point cloud is a means to an end, in the sense that we can create virtual tours. We can analyze a flatness of a concrete. We can create CAD drawings or 3D models from that point cloud, because it represents dimensionally what is actually in the real world. For you that are maybe thinking about it, maybe you've had some thoughts about scanning, there's a few key things to understand, and these are the things that we often come across when we speak to customers, particularly new. One is, it's not an X-ray machine. I said that already. Some people believe, it can see through walls. It can't. If the scanner, this device that you see on your screen, if it can't see the object, it won't be able to measure it. It won't be able to capture information on it. So things like a room full of MEP components, so lots of pipes and electrical conduits, If there's pipes behind pipes, then we may not be able to measure those pipes behind pipes. We'll only be able to create the surface in terms of see those pipes and those walls that are on the visible to the scanner itself. It operates in the dark, as I said before. It doesn't need light to operate for the laser element part. It isn't 100% automatic. You know, these devices are very intuitive, and it's very easy to scan. As I said, the art of scanning is actually putting it all together into an accurate deliverable. And we're talking about accuracies of, you know, quarter of an inch, half an inch better kind of thing. So scanning thousands of times and still getting that accuracy is where the work comes in. And that's where that registration is key. So that's the industry term for linking all the scans together. And it's critical that that's done correctly to get an accurate representation of the real world. And then deliverables, maybe doesn't mean anything to you, but typical deliverables, if you're an Autodesk user, which I'm guessing the majority of people on the call are, you'll probably know Recap as a product. That format, the Recap format, is a common format that most of the industry ask for, and most scanners today can spit out and produce a Recap format that essentially means you can open a point cloud directly inside AutoCAD, inside Revit, inside Navisworks. The LGS format is a Leica Geosystems format. They're the manufacturers of the scanner, and they provide some very good pieces of free software that allow you to open up the point cloud and view it. And then for everyone else that's using other software, maybe ArchiCAD or Bentley or some of the other 3D packages, an E57, I guess, would be akin to an IFC for point clouds. So if IFC is the open standard, the open format for BIM, E57 is the equivalent for point clouds. Most, if not every piece of software that can open a point cloud will accept an E57 file format. And the other thing would be say to not all scanners are created equal. I mean, there are scanners and they range in price, they range in range in terms of scanning distance, and really understanding what scanner is being used will help you as well. Because, you know, something that may take half a day with one scanner may take 2 days with another, just because of the parameters in which it scans. So understanding that is quite key. And we believe the scanners that we use, which is the Leica RTC 360, is probably one of the best on the market at the moment. In terms of workflows, I'll go into a little bit more detail when I get to the CAD and BIM side of things. But really, we kind of have two main parts, and that's firstly renovation workflow. So we do a lot of work with architects, developers, asset owners that want to renovate their facilities, whether that's a residential property, whether that's a commercial property, whether that's a university campus. Essentially what you can do is we can go out and scan, or you can go out and scan it, capture reality, get an accurate picture of what the world looks like out there, and we can use that for virtual tours. And that's what I'm going to hand over to AJ in a minute, and he'll take you through some tools that we use that allow lots of different people to connect to the data. It's also a perfect starting point for any CAD drawings. So because we have this accurate 3D data that we can open in AutoCAD, inside Revit and so forth, we can start to create floor plans, elevations, ceiling plans, Revit models based on that accurate point cloud. So essentially, very common as we deal with architects and developers, and they want a point cloud, but at the same time, what they really want is a CAD drawing or a 3D model so they can start their project in terms of designing and understanding what exists on the project today. Moving through into the construction phase of it, scanning is being used as a validation tool. So if you imagine you've got your design model and essentially it's being constructed in the real world, we all know that there's always discrepancies between design and construction for various reasons, and potentially those discrepancies can cause, you know, impact financially, negatively. So what some companies are doing, and we do it for some companies as a service, is we go in and we scan their construction at key milestones. So we'll validate a slab, a pre-slab, so to validate whether all the rebar or the inserts or the cut throughs and so forth are in the right location before it's covered up with concrete. Or we scan the MEP, so all the piping, the electrical, mechanical components before it gets covered up by ceilings or walls and things like this. And it becomes their milestone to validate against the design model, or as a kind of a snapshot in time that they can use downstream to de-risk any kind of FM work that they might be doing. As well as that, you can use it for clash detection. You know, I want to design something, put it in a room, give me an accurate representation of what the room looks like. Scanning is a very good way of doing it. And you can clash models against point clouds, so you don't necessarily have to model it. And then finally, one of the other workflows I wanted to talk about is floor flatness, or just analyzing the point cloud. So we do this for companies. When you pour concrete or you install something that needs to be vertical, scanning, basically we spray paint with points the walls or the floors, and we do this thing called heat mapping, where it gives you a very visual understanding of if something is flat, if something is vertical, if something is in the right place or the wrong place. This is very useful during the construction process, particularly for hospitals or high-end commercial buildings. You know, we're working with several companies where they have automated robots in terms of moving stuff around on a particular floor, and the floor has a very tight tolerance. So analyzing that flatness is key to them being successful. So really, I'm going to warn AJ, I'm going to hand it over to you in a second, AJ. Really, with scanning, you know, digitally capturing your whole world in 3D is a huge benefit to a lot of people. Being able to capture accurate 3D data, to replace outdated information, to ensure the accuracy of the data that you're starting your project with. You know, do these floor plans that I'm starting my design with accurately represent it? Or maybe not, because they're 10 years old, they're 5 years old, and I don't actually know how accurate they were in the first place. It's a complete 3D picture, which AJ will show you in a second, and really it's about starting your project right. So AJ, I'm going to hand it over to you, if you don't mind.
Perfect, thank you, Mark. Let me just grab hold of the screen here. Can you confirm you can see it, Mark?
It's thinking, yep, I got it.
Perfect, perfect. Hello, everyone. My name is AJ Ballou. I've been with Multivista for about 10 years now, working in reality capture and working alongside Mark. And I'm just going to cover how Multivista helps to offer collaboration tools and really showcase the data that is being collected through laser scanning in a way that kind of makes it seem familiar to a larger audience, perhaps, than maybe a smaller audience that may be a little less familiar with dealing with purely 3D point clouds and models and such. So the Multivista platform has been in existence for over 15 years. It's an online tool where individual projects are set up on an online platform, and as many users can be added as necessary. And what we've done in the past is we've always indexed photos, videos, files to floor plans. And with the adaptation of laser scanning, we've done just that. We've tried to democratize the information and showcase it in a format that is accessible to more and more people. So what we're looking at here is just a standard 2D floor plan. And you can see these markers, we call them drop spots, that you can hover over that might show you kind of key locations throughout the floor plan. They are date stamped with a preview image there. I can also turn on a visibility to see where else scans may have been taken in relation to this floor plan. So if we dive in to one of the locations here, you're now entering a product that's made by our sister company, Leica Geosystems, that's now plugged in and embedded into our system. And as Mark described earlier, the 3D laser scanner, it's actually doing two passes when it's out in the field. The first is to collect that high density laser information, where it's just spray painting the entire environment with billions of points. And the second pass that the scanner actually does is collecting HDR imagery. So as Mark mentioned before, you can scan without imagery, but being an image-based company, our standards are to provide colorized imagery for nearly all of our projects unless requested otherwise. So what you have here is a pretty standard photo, but it offers you that information that is a little bit more user-friendly than perhaps staring at a point cloud, which we'll jump into for comparison shortly here. But what's nice about this is what you don't see is those millions and billions of points that sit behind. So what we have is a few different tools that allow us a few different viewing capabilities or collaborative options. So we're viewing the RGB layer, the color imagery layer at this point in time. If you wanted to get an idea of the points, and as Mark said, the laser scanner actually works in the dark. It does not need light to work. this would be an example of something, an environment, or the data that you would receive or be able to view in an environment where there isn't any light. You will always be able to get at least black and white data for it. And as Mark also mentioned, we can also assign colors to the intensity, and this is called intensity hue, and is another layer available as well. What's nice about it is because there is those data points sitting in behind the imagery, it becomes measurable. And we have a measuring tool here that is fairly accurate. It is not meant for design purposes or for installing windows or that sort of thing, but to generally conceptualize the area, it becomes very useful for interior design or basic design, or calculating materials in terms of what can fit through which openings, or how much space is there to situate various materials on site. You'll notice that units of measurement can be changed. It can be changed in this tab here. There's a number of different options down the page as well. You can also scale on more visibility to other locations that have been scanned. So each one of these orange spheres represents an area where the physical scanner was situated and did its 360-degree rotation. I can also utilize this mini map in the lower right-hand corner to jump to a different position. Takes a second to load, as there's so many data points that need to be calculated behind the scenes. You'll notice here as well, there's a few different sample, what we call geotags. You can simply place them using this tool here within the panoramic imagery, and then you can attach either photos or files. The photos may be photos that already exist on our system that have been taken by a Multivista technician on site, or they can actually be added by the user or people actually working on the site themselves. So Multivista does have a mobile app that works on both tablets and smartphones. And if you're, for instance, on site and you dig a hole and expose some underground utilities, something like that, you can take some photos, upload it, index it to the floor plans, and it becomes viewable to either just yourself, or you can assign it and make it viewable to a larger audience on your project team as well. So it becomes a useful collaborative tool utilizing that point cloud data overlaid with imagery as that fundamental base that kind of helps you perform some of these different aspects. Another tool that is really useful is a snapshot tool. Freeze frames the image as you see it. I can add in another photo here. And now all of a sudden I have different markup tools available to me as well. If I want to measure the length of this window, for instance, I can choose to save it here. I can utilize other features that are involved in the system, save it to either an album that I've created within the Multivista system, save it directly to my computer, email it, print it, really be able to showcase findings that you find in this environment with other team members as well. One thing that the platform cannot handle at this point in time, and it's a bit of an industry-wide issue at the moment with point clouds collecting so much data, is how do we view them? And it's really hard without severely decimating the point clouds themselves to be able to view them in an online environment. And as I mentioned before, not everyone's able to understand exactly what they're looking at when they're looking at a point cloud. So let's take a look at this exact same project in a free offline viewer provided by, again, our sister company, Leica Geosystems. It's formerly been known as Jetstream Viewer, has recently changed to the name TrueView as well. And what we're actually taking a look at here are those billions of points collected by the laser scanner. So if you're to zoom in, you can actually pinpoint individual points as we look at blades of grass here, but the same goes for any surface and object that the laser scanner is situated around. There are some types of surfaces that laser scanners just purely don't work as well around, including water or highly reflective surfaces like glass and whatnot. So when we're taking a look at this nice point cloud here that's been nice and cropped, we have relieved it of much of the noise that may have been extruded through some of the glass and window or surrounding buildings and whatnot. So every time any one of our technicians or anyone who collects 3D laser scan data typically goes through that registration process, but they also go through a cleaning process as well to eliminate unnecessary information, help to reduce the overall file size, and then clean up any sort of reflections and noise as well coming from glass or those reflective surfaces. The reason that is we're viewing this in an offline viewer is point clouds, depending on how many scans have been taking place on site, can exceed, multiple gigabytes, hundreds of gigabytes. They can be quite large, which makes them a little bit heady to share and make it a little bit less accessible. So that's why this offline viewer, which again is free, you just need to have one of our standard point cloud published files, an LGS file, to be able to open up this data in this environment. So as we're looking at the imagery again, you'll notice that there is much information that kind of wasn't included in the point cloud data. I can see buildings, I can see mountains in the distance, I can see those further away. And let me expose some of the tools up here as well. If I was to turn on the point cloud and turn off the imagery, we would just see what has actually been collected in the data or has been filtered out and cropped out. Same capabilities to be able to measure. You can do fly-throughs around the environment. It can actually utilize limit box features as well. So if I go back in, maybe view it from the top down, remove the roof, can then expose the entire environment. I can utilize the manual limit box creator to size up and maybe view a particular room or exterior face of a building, really analyze it to measure wall thickness or really get an idea of this layout. And like I said, you can crop it if you only want to view the floor or an isolated particular area, which becomes quite useful. And what a lot of people find useful as well is kind of diving back and forth between this environment as well as the panoramic imagery as well, so that you can soon see what it looks like in real life to kind of confirm potentially some of your biases as well. What is nice about this offline viewer as well, and Mark will go into it a little bit more detail as I reset this point cloud here, is the ability to utilize this point cloud as a bit of a stepping stone to create end deliverables. Multivista offers 2D CAD drawings as well as 3D models as well. But what this offline viewer does expose is or present is the ability to showcase the model that's been created as well. So by nature, it won't automatically create. This is a service that we have to provide, whether clients create the model themselves or Multivista offers this as a service, but you can actually embed and import the model, the IFC or the Revit drawing into this point cloud environment, align them together, and you can actually toggle back and forth between model, point cloud, imagery, which really kind of gives you a little bit of that trifecta in terms of being able to distinguish what is being planned versus what is actually there, and confirming and being able to take measurements from the model and seeing how it's situated in a real world environment in relationships to adjacent buildings and vegetation and things like that. So it just provides a nice tool that makes it a little bit more user-friendly for many people in a lightweight environment, and you don't have to be as familiar utilizing some of these bulkier and heavyweight 3D applications that are currently available on the market. Mark, I will go back to you to kind of explain how we get to some of those end deliverables that we just touched on.
Can you see my screen, AJ?
I can.
Okay, perfect. Yep. So AJ just took us through connecting teams, and really some of the tools that he showed. The first one, online, and I would say one of the biggest barriers that scanning has seen in its kind of 10, 15 year existence, maybe a bit longer, is the huge data sizes. I mean, we can't hide the fact that when you do a lot of scanning, you get a lot of data, and we're talking about gigabytes of data, and that becomes very a bit of a barrier to people effectively using the data. So typically, we have different levels. So we as a company really value the online viewer that we've created, and I think a lot of our customers do, because it, as AJ says, it democratizes data. It gives people access to the information without having to install, download huge data sets, special software. It just runs. For those that are more familiar with the 3D environment and have the the capabilities of doing it, that point cloud is hugely immersive, hugely rich in information. And then finally, bringing that into your AutoCAD, Autodesk, BIM world, and using it as a basis for analyzing or modeling or drawing and so forth. And I'll cover a little bit about that whole CAD and BIM side of things now. So as we talked about, point clouds are often the means to an end, and the end is often, particularly in renovation projects, particularly for facilities management, when they want plans to plug into their FM software, they're looking for CAD plans or 3D models, specifically Revit models in many cases, because of this BIM drive, to be created from the point cloud. And the point cloud is a very good and accurate way to bring that real world data into that software and model and draw accurately based upon it. So as a company, we typically use AutoCAD and Revit. The reason being is because most of the customers we deal with use Autodesk, AutoCAD and Revit as their tool of choice. Other tools are available, obviously, and other service companies use other things as well. But we have the ability to use that, plug it into the software, and create those typical deliverables that I'm sure most of you are very familiar with today. The one thing I would say is there is no magic button for creating floor plans or models from point clouds. There are certainly tools and some software add-ons that help you speed up the process, but there isn't a button in Revit that says create model from point cloud. You go away from an hour, then suddenly it appears on the screen. It is still a very manual process to model and draw from point clouds and models and so forth. The reason being is, a building is typically very complicated. A lot of automated tools just can't deal with that complication at the moment, and we hope in the future it will do, but at the moment there isn't. So it can take time to create something from the point cloud. Hence why, again, we value that online tool a lot, because typically when our teams go out and scan, we can deliver the online tool to our customers very quickly. And if it's a huge project, it may take several weeks to do a Revit, very detailed Revit model. So in that meantime, they've got the online tool to start measuring and understanding until the deliverable is ultimately ready. Some critical points to understand. First one is scope. I mean, we have this a lot in terms of, what do you want modeled? What do you want drawn? Because effectively we've captured a lot of information. We can model and we can draw a lot of information, but is it actually required? It becomes a price, effort, kind of need sort of equation. And actually, we have a checklist that we give out to customers, and we say to them, the more boxes you tick on that checklist, the more it's going to cost, the more time it's going to take us to create it. So really, it's about finding the scope that means that you need this type of model that includes these types of components, because this is what you need. You don't need to model this. It's going to cost you more, and actually you don't really need it. And the point cloud is already going to give you enough information for you to make any decisions you need to. That reason, that purpose is key. The way things are scanned, the way things are drawn and modeled can be based on the purpose. If the focus is on, removing certain things or keeping certain components, the structural steel is critical. We need that to be critical. Well, when we can focus effort on those sorts of things. So understanding the purpose often drives the way we scan and also the way we create the deliverables as well. A tip for you guys, if you don't know already, the US Institute of Building Documentation, the USIBD, they have some very useful standards called level of accuracy that basically covers scanning and the conversion of scanning to drawings and models. I highly recommend going on their website. It's a free download. I think you have to sign up, but you can get a couple of their guidelines. And it talks about the different levels of accuracy that can be stated when it comes to scanning, and also scanning conversion into point clouds and model and into drawings and models. Sorry. The other one that I would say is software limitations. I'm sure quite a few of you are familiar with Revit, and to be honest, any of the 3D modeling packages often have limitations in terms of, they like things to be flat, they like things to be horizontal, they like things to be 90 degrees and vertical, particularly Revit. Revit throws up a lot of warnings. So modeling real world situations, we can model very accurately to a point cloud. The issue we have is it takes longer. And two, Revit doesn't particularly like it in some cases because it's not 90 degrees horizontal vertical. So it's again working on that scope to understand what is required and when we need to put that in. And there are limitations. We can't really model every distortion in a pipe run that goes from one end of the building to the other. We're obviously going to model it very accurately, but every sag, every dip is not something that we tend to model in there. And then finally, level of development. In terms of LOD, I'm sure something familiar with you and the AIA, of course, one of the key developers of that. Scan to BIM, or as we call it in terms of creating the models, effectively, we model what we see in the sense of we are only very superficial. If we scan a wall, we have no idea what's behind the wall. We may know the thickness of the wall, but we don't add any information into the models that we create for our clients. We're effectively giving them geometry that represents the correct size, shape, location, and orientation. And typically that's what you get when you do a scan to model side of things. The information that you may get from designing from scratch in terms of understanding material properties, maybe exact types that you want in terms of other information, you don't get that necessarily in a scan to BIM model because we only capture the surface. We only say, okay, there's a column there and it's of this size, shape, and location. We have no clue what rebar's inside. We don't know that information, so we don't put it inside the model. Just to bear in mind with that. As I said, what we do is, and what the industry does in terms of scan to BIM is you model accurate geometry inside Revit, or you draw it inside AutoCAD in terms of size, shape, location, and orientation. It's modeled within Revit in typical Revit categories, systems and families. It doesn't contain any material or other element information. It's just what it is. That's it. That's a roof. We know it's a roof, but we don't know what type of roof it is. And then it's sometimes referred to as a BIM ready model in the industry, where it doesn't contain all the information that maybe you need, but it's giving you an accurate representation of what the world looks like geometrically in your software. In terms of scan to plan, lots of different options, but effectively, as I said, the point cloud is a great tool to be able to create drawings from. So in this case, floor plans, ceiling plans, elevations, building sections, and site layouts. And we use it as a framework, and we essentially draw over the top, slice the data, slice it where we need to, and get the information we need. So, 2D CAD's typical deliverable and very common for architects and developers that we work with. Same thing with scan to BIM. The way we structure it is we have architectural base models, so which covers walls, floors, ceilings, and so forth. And then we have add-ons. So if you need mechanical added in, electrical, plumbing, other components, then there's extra cost because it takes extra time and effort to do it. And typically this is how we structure our scan to BIM project. So do you want all the MEP continued? Most of the time, most of our customers, I'd say 70% of the time, most of our customers are just looking for an architectural model where they're wanting similar sort of thing, walls, floors, doors, windows, common plumbing fixtures included in a 3D model based on the point cloud. And really, I mean, as we've covered today, scanning is kind of, maybe 5 years ago was fairly new to the design realms, to architects and developers and so forth. Today we see this a lot. I mean, like I said, Multivista as a company has kind of 25 scanners operating in 22 different markets around the world, mostly in North America. And we have probably every day, there are multiple people out there scanning for design purposes, for construction purposes, for facilities management. And really it is about capturing accurate representations of the real world. AJ showed you about how we can connect teams, whether by a web, where you can actually start looking at the data, interacting with the data, and understanding what you have, or dealing with the point cloud itself. And then I talked about the fact that we can take those point clouds and we can start plugging them into Revit and AutoCAD and other 3D packages and start to create deliverables like CAD and BIM based on the back end of it. So that's really the three steps for us. And to us, we're representing the industry, and really this is common for the industry as well. I would say the only unique thing to Multivista, apart from our kind of legacy, is that online tool. We really value that, and that's fairly unique to Multivista going forward. But yeah, thank you for listening today. We really appreciate your time. If you do have any questions, me and AJ and Jason are here for the next few minutes, and happy to answer any questions you had on scanning, reality capture, scan to plan, scan to BIM. Really appreciate the time. Any questions?
Thank you, Mark. I don't see
Nice.
any questions in the chat just yet.
Okay.
There we go. In the classroom model, was the furniture scanned or captured by camera?
In that one, it was scanned. So so the furniture that was in there would be in the point cloud essentially. It wasn't modeled because that's typically not required, but it's in the point cloud that we collected. Yeah.
And just a reminder to everybody on the call still, please use the second link that is in the chat. The first one was sending you to the spring lecture series, which is not happening at the moment. It's the wrong link.
Hey folks, this is Jason Donahoe. I'm the senior regional partner here in the Mid-Atlantic footprint of Multivista. I got a preview of who was joining today, and we've worked with all of you in one capacity or another. And I can reach out to your firms individually, and we can host one-offs, lunch and learns for credit hours. So just feel free to reach out to Margaret or me directly, and we can schedule that for your entire team and get you guys a credit hour and get you updated on the latest in shareable reality capture data.
And Margaret, there's one second part to that question that I didn't answer. So one of the questions is, in the classroom model, was the furniture scanned or captured by the camera? Was eliminating the furniture from the model part of the cleaning process? So it's a good question. So with the scanning, as we said, it captures everything. We spray paint everything that it can see. So it would have scanned, and we would have 3D measurements and probably millions of points on all the different chairs and tables, cupboards and so forth inside the building itself. We don't typically clean that or remove that because it's just part and parcel. When we bring that into, say, Revit or AutoCAD, we essentially, unless we're modeling or drawing it, we ignore it. We don't need, it doesn't need to be removed because it doesn't really impact how we model a floor. We just need some levels on the floor to model the floor. It won't impact the walls, things like that. So we typically don't clean it per se. We don't delete it from any data set. We leave it in there. The only data that we clean is potentially, what's the word? Incorrect data in the sense. So for instance, if you were to take a laser scanner and set it in front of a mirror, you effectively get a reflection. So you get extra data that you don't need. We would do things cleaning that sort of information that is incorrect. Furniture, we typically leave in.
And another question, for architects to be present during the scanning, is there a way to also get a feel for the building? Is it okay for architects to be present, I guess, in the scanning?
I mean, I'm sure it can. I mean, I'm sure it's been done. I would say it's uncommon for our clients to be on site unless there's maybe access queries where they have keys and access to various places that we need to get with the scanner. I guess you can, and sure you'll get a feel of it. I mean, I would say that scanning itself and the online deliverable, I mean, it gives you a virtual tour. So maybe you don't necessarily have to do that too much because you'll get this virtual tour afterwards. That would be my answer to that. Typically, we don't have our client on site unless there's reasons for access or keys and fobs and all this kind of stuff.
Okay.
I'm sure Jason would welcome you on site if you wanted to attend site with him.
Absolutely.
Yeah.
Military bases included.
All right. If there's any other questions, drop them in the chat. If not, we can wrap up.
Okay.
Well, that was a great presentation. Thank you all. And thank you everybody for joining us today. And we'll hope to see you at one of our next events.
Perfect. Thank you, Margaret. Thank you, everyone.
Thank you.
Bye-bye.
Thanks,
Thanks,
everyone.
everyone. We appreciate it.